Hello YouTube viewers, welcome to this video, and in this video I'm going to talk about the resource quotas and limits that you can apply to your Kubernetes cluster. Right, in my previous video I think I covered the config maps. So this one is entirely different, resource quotas and limits. For this video I'm going to use micro K8s cluster. If you haven't watched that video, I've already done a video about how to set up a single node Kubernetes cluster using micro K8s on Ubuntu machine. So that's what I'm going to be using here. Usually I'll use my 3-node Vagrant cluster to bring up the Kubernetes cluster for all my demos. But these resource quotas and limits, they don't need multiple nodes. So just to keep the resources to minimum, I'm going to deploy micro K8s. Actually, I've already created the micro K8s cluster, and I'm going to show you how you can use the resource quotas and limits on your cluster. Okay, so I'm on my virtual machine. I've logged into my Ubuntu 18.04 virtual machine. As I said, please follow my other video about how to set up micro K8s if you want to follow along this tutorial. So if I do lsb release, so I'm on Ubuntu 18.04, which is a virtual machine running on my host machine here, and I've got micro K8s installed. So if you've got Ubuntu 18.04, you can check sudo systemctl status snap, I think, or snapd. Okay, so that's the snap is a package manager which gets installed on Ubuntu 18.04, but you can also install that on any Linux distribution. Okay, so once you install that, you got to do sudo snap install micro K8s -- classic. So that will give you a single node Kubernetes cluster, which I've already done. Okay, so resource quotas and limits. If I cd to play directory, I haven't got anything, and I'm going to clone my GitHub repository. By the way, the GitHub link are in the description if you want to check out. I'm going to cd to Kubernetes and cd to YAMLs. So I've created few YAML files for this demo. Okay, so resource quotas and limits, resource limits. So how would you do that, or why you would want to do that? If you're learning Kubernetes on your own cluster, then that's not a problem. But in the actual use case, in the actual production environment, in your organization or any corporate environment, if you've got a cluster, there will be multiple teams using that cluster. So you don't want a particular team or a particular user to use up the entire cluster. So you got to specify some resource limits, some quotas for the users to use, so that they don't exceed their quota, so everybody get a fair share of the cluster. So that's why you want to use resource quotas and resource limits. Right. How this actually works is by namespaces, and I've done a video on namespaces. It's basically a partition in your cluster. So uh, think it as a partition of a hard disk. So you've got a big hard disk, you partition the hard disk, and you store data in each partition. So similar to that, you've got your Kubernetes cluster, you're dividing your cluster into namespaces, and the resource quotas and the resource limits applies to namespaces, not to the entire cluster. So you can have a production namespace, if you can create a testing namespace, you can create a staging namespace, QA namespace, or so on, or you can create different namespaces for different projects or different teams, and you can apply the resource limits to specific namespaces. Okay, so before looking at all these YAML files, the first thing I'm going to do is I'm going to create a namespace just for this demo purpose. kubectl create namespace quota demo ns. Okay, so kubectl, actually I wanted to show you my micro K8s setup. Micro K8s dot status. So micro K8s is running. If I do kubectl, by the way, If you install microKATIS, the normal command would be microKATIS.kubectl, but to save some time in typing, I've created an alias for kubectl. So kubectl refers to microKATIS.kubectl. So if you wonder why kubectl is not working in your microKATIS cluster, this is possibly the reason. I've created an alias. So kubectl cluster info. The cluster is running kubectl get nodes. I've got one node, which is the virtual machine itself, Ubuntu VM01, kubectl version. Okay, so I'm on version 1.13.1. If you follow this video in the future, you might get a different version, but all these concepts should work very well. Okay, so now let's check the namespace that we created. Kubectl get namespaces. So Kota demo namespace, that's the one we created 79 seconds ago. Okay, let's take a look at the YAML files. What I'm going to do now is there are two things you can do. One is the resource quotas, the other one is resource limits. We can look at the resource quotas first and then look at the resource limits. Okay, so resource quotas tells you how many the quantity of the resources that you deploy in your cluster. For example, you can say for this particular namespace, I don't want more than 100 pods to be created, or more than 2 jobs to be created, or more than 5 cron jobs to be created. You can restrict the number of resources that can be deployed into this namespace. So if I show you this example, you would understand it better. Quota count.yaml. So I'm creating a resource quota called quota-demo1, and I'm creating this resource quota for the namespace quota demo ns, which I just created. So I'm the specification, I'm specifying that no more than 2 pods can be created in this namespace, and no more than 1 config maps can be created in this namespace. So the type of resources that you can use for quotas are pods, config maps, basically any resource, jobs, cron jobs, services, deployments, replica sets, stateful sets, and so on, everything. Okay, but in this case, just for this demo purpose, I'm just showing you a couple of resources, pods and config maps. So basically, we are creating a resource quota object with the name quota-demo1, and in the namespace quota demo ns. So that's very important, namespace, because resource quotas applies to namespace, not to the entire cluster. So okay, let's try that. kubectl create -f. So that resource quota is created. Let's take a look. kubectl -n and the namespace describe quota demo1. Okay, so the resource quota we defined for this namespace is here. The limit is we can create 1 config map and 2 pods. Let's test this out. I'm going to create a config map, kubectl -n quota demo namespace. So this will work only if you create the resource on that particular namespace where we have created our resource quotas. Okay, create config map cm1 from literal equals name equals Venkatan. So this is just a very simple config map. By the way, I've talked about the config map in my previous video. Okay, so that config map is created. kubectl -n quota demo ns get config maps. So that's there. And now if you look at the quota demo ns describe quota, so I can see the limit is 1, and currently we are using 1 config map. So now let's try to create another config map and see what happens. I'm just going to change the name of the config map from 1 to 2, and you will get this error, the error forbidden, because it has exceeded the quota requested. So what we have requested to create one config map. There is one config map already used, and the limit is set to 1. So we are exceeding the limits set for the config maps in this case, especially in this namespace. So it won't allow you to create more than what you have specified in the request quota. Cool. Okay, so let's come to the pods now. So as you can see here, the pod, we can't create more than 2 pods in this namespace because of this resource quota. Let's try and do it. But before that, I'm gonna delete the config map. kubectl, just to properly clean up. Delete config map cm1. So that's deleted. Let's try to create an nginx pod. kubectl -n quota demo ns, run nginx image equals nginx -- replicas equals 1. Okay, so we've created a deployment set with 1 replica of nginx. Let's take a look at the quota usage. Quota demo ns, quota demo ns describe quota demo 1. You can see here of the 2 pods, we already created 1 pod. kubectl -n quota demo ns get pods, get all. So you can see here we've created the deployment with 1 replica of nginx pod running with 1 replica set. So that's cool. Let's try to scale it. kubectl -n quota demo ns scale deploy nginx - replicas equals 2, for example. And let's look at the quota usage now. Quota demo ns. You can see here we have got 2 set for the limits, and we are currently using 2. Get all. So the deployment, we are using 2 nginx replicas are running. The replica set is happy. So now let's try to increase replica count to 3 and see what happens. Replicas to 3. It says it's scaled, but if you look at the get all output, the replica set desired is 3, current is 2, ready is 2, and the deployments 2 out of 3 are ready. And you can see only 2 pods are created. Okay, so now let's take a look at the replica set. kubectl -n quota demo ns describe replica set, and I'm going to copy this one. Okay, and you can see here current is 2 and the desired is 3. Only 2 is running, and if you look at the events here down at the bottom, it says error creating pod is forbidden. So it has exceeded the quota. So we've requested 1 pod. We've already used 2 pods, and the limit is set to 2 pods. So that's how the resource quotas work. Okay, let's delete all these. kubectl -n quota demo ns delete deploy nginx. Let's take a look at now. kubectl -n quota demo ns get all. Okay, so we've completely cleaned that up. Okay, so I've shown you a demo of how you can use resource quotas in a particular namespace to limit the number of resources you can create. We have seen the config map and pod. So this can be applied to any type of resources, jobs, cron jobs, and all resources basically. Okay, so now we can move to the resource limits. Limits are basically applied to CPU and memory, storage. So I'm going to show you an example of memory here, and you can follow for CPU, which is going to be very similar. So I'll show you an example of how you can restrict memory usage. The use case would be, say for example, you create a namespace for the testing environment in your organization, and you create another namespace for production environment on your cluster. So you want your testing environment namespace to have limited memory availability, and your production namespace to have more availability for memory. And you can define, you can restrict how much memory the namespace can handle. It's not for individual parts, but it's for the entire namespace. So if I show you an example, it will make you some sense. I've got quota mem.yaml, so that's basically it. So we are creating a resource quota, and we are applying that to the namespace quota demo ns, which we have already created. And the limit we are applying is to the memory, limits.memory 500 meg. So which means this namespace, quota demo ns namespace, the collective usage of all the pods cannot exceed more than 500 meg of memory. So you are just allocating 500 meg of memory to this entire namespace. So you can keep creating pods, replicas, and everything as long as it's within 500 meg limit. So once it exceeds that, you won't be able to create more pods. So this is based on the resource and not based on the amount of resource. You know what I mean? This is not restricting you for the number of pods you create, but the amount of memory all the pods collectively uses. So in this case, the namespace quota demo ns has an upper limit of 500 meg of memory. So let's apply that. kubectl minus n quota demo ns. I'm gonna see what other quota I've got. So I'm gonna delete that one. Okay, so that's deleted. Let's apply the new one. kubectl create minus f. Okay, that's created. kubectl minus n quota demo ns describe quota, and it's called quota demo mem. So we have set the memory limits to 500 meg. Okay, so now what I'm going to do is I'm going to try to create a pod, and I've got a YAML file for that, which is this one here. Let's try to create it. Okay, but before that I want to show you what's inside that YAML file. That's not the one I wanted. 7 pod quota mem.yaml. So as you can see here, it's a very simple pod specification. I'm just deploying a pod into the namespace quota demo ns. It is going to fail. I'll show you why it's failing. kubectl create minus f and that YAML file. Okay, so that's failing. It's because you're deploying a pod to a namespace which has resource limits set. So if a namespace has got a resource limit set, so we've got this resource limit quota demo mem set for this namespace. So if it's set, you have to specify the limits in your pod specification. So let's go back and set that. So basically you want to tell how much resource your pod will be using. So I'm going to say resources and limits memory. I'm going to say my pod uses about 100 meg of memory. So you have to specify the limits, otherwise as you saw, it won't let you create the pod. It will give you error. So when you have a namespace with resource limits set, you have to specify the limits inside the pod specification. If you don't want to specify the resource limits for every individual pod or deployment you create, that is one other way, which I will show you in a minute, where you can define a limit range, a default limit range, so that you don't have to specify individually on every single resource. You can create a default limit range that gets used for all the resources you deploy in that namespace. Okay, first let's look at how this one works, and then we can go and look at the default limit range. Okay, so I'm going to create an Nginx pod. I'm saying my pod will not use more than 100 meg. It won't be allowed. The cluster won't allow the pod to consume more than 100 meg of memory. kubectl create -f. So now you can see the Nginx pod created. If I look at the quota usage now, quota demo ns describe quota, you can see the limit is 500 meg, and currently we are using 100 meg of the namespace, and you can create as many deployments as you want as long as it's within the limits. If you create more than that, it will fail. So we are setting the upper limit of 500 meg. Okay, let's delete that, and I'm going to show you what it's going to do when we request more memory than what's available in your namespace. Say for example, if I say my pod can use up to 800 meg, but we've only got 500 meg available on our namespace. Let's see what it's throwing us. Okay, so that's here. Nginx already exists, which I knew. I need to delete that before I deleted the resource limits. Okay, so I meant to delete the pod. Delete -f7 pod. Okay, the pod has been deleted. So what I did now was change the memory limit to 800. As you know, the resource quota, we've defined only 500 meg of upper limit, so this is going to fail. Let's see how it fails. kubectl create -f. What's going wrong? Create -f. Okay, so now you can see it has failed because it has exceeded the quota. So what we requested 800. We've set the limit for the pod to be 800 meg, and the limit that's available to us was just 500 meg. Okay, the other thing I wanted to show you was limit range. So I'll go back and delete the resources. So it's just a basic pod specification without any resource limits or resource requests set. I'm going to save that, and if I create it, it's going to fail because we need to specify the limits. The other way you can do is you can create a default limit range that gets applied to all the resources inside the namespace. Okay, let's take a look at what's in that YAML file. Okay, so we are deploying a resource limit range into the namespace quota demo ens, and I'm specifying the default memory limit to be 300 meg and the default request to be 50 meg. Type is container. Okay, let's create this one. kubectl create -f. So that's created. If I do kubectl -n quota demo ns get or describe limit range mem limit range, you can see the limit range we have defined for this namespace. So we don't have to specify the limits inside the pod specification. So if I create the pod specification now, 7 pod mem.yaml. So now the pod is created. It's the same YAML file without any resource limits set inside the specification. So that's because it's using the default we've defined for this namespace. So that's how you use it. Okay, let me delete that. And I want to show you one more thing. kubectl delete -f quota limit range. Okay, so I've deleted everything. I'm going to open the mem.yaml. Okay, so we've defined the limits.memory, and that is called requests.memory. I'm going to set that to say 100 meg. What this means basically is you're defining a resource quota for the namespace quota demo ns, and the limit you're setting is all the pods collectively cannot use more than 500 meg of RAM of memory in this namespace. And requests.memory is the maximum amount of requests that a resource can request is 100 meg. So if I show you an example, it will you will better understand it. So requests.memory is the maximum amount of memory that you can request. Okay, so I'm going to edit the pod specification now. Because I've deleted the limit range, I'm going to specify to show you how it works. Resources limits. We are setting the memory limits. So if you follow this, it's going to be the same for CPU, number of cores. So I'm just explaining memory here. So say for example, I want my pod is not going to use more than 200 meg. Okay, so if I just leave it here, let's see if it works. It won't work because we have set both the limits and the request. So but on the pod specification we have defined just the limits, and see if it works. kubectl -n quota demo ns describe quota. Okay, so we haven't applied the modified file. kubectl apply -f quota mem.yaml. Okay, that's applied. So now you can see the memory limit is 500 meg, and the memory request that can be made is a maximum of 100 meg. Okay, kubectl create -f and the pod. Let's try to create it, and it failed. That's because we have got both the limits and the request set, but in the pod specification we have only specified the limit but not the request. Bear in mind, if you don't specify requests, so there is limits and there is request. So if you don't specify the request, it's going to assume whatever you have given in the limit is going to be used for request. You can see it here. In the pod specification we have defined the limits to be 200 meg, and that's why it's using the 200 meg for the requests as well. So let's go back and edit that. So here whatever you give in the limit, it's going to get applied for the requests. Requests memory. So this is what happened. If you don't specify requests, whatever you have given in the limits, it's going to get applied for requests. But since we specified in the resource quota that the maximum amount of memory that a pod can request is 100 meg, that's why it's failing. So if I change this to 50, for example, it should work. kubectl create -f. Okay, the Nginx pod has been created. If I do kubectl -n quota demo describe pod Nginx, you can see the limit 200 meg and the request 50 meg, which we used in the pod specification. Okay, let's delete that. Kubectl delete -f7 pod.yaml. Okay, so that has been deleted. I'm going to make a small change. For example, if I say 150, for example, kubectl -n quota demo ns describe quota. So we have specified that the maximum memory that it can use is 500 meg and the maximum amount of memory it can request is 100 meg, but we've changed that to 150, so it's gonna fail because the maximum it can request is only 100. kubectl create -f, it failed, so that's it. Okay, I think that's all I wanted to show you. I was a bit quick in this video. Hope you are following this video. If it's not working for you, or if you can't follow this, please leave me a comment and I should be able to help you. And it's a very interesting thing how to set the resource quotas and resource limits in a big cluster. So for learning purpose, it's not a big deal. It doesn't matter much. You're using a single node Kubernetes cluster, or if you're using a multi-node cluster, that doesn't matter if you're the only person who is using the cluster. But when it comes to the actual corporate environment kind of production cluster, then you need to have all these resource limits set in place so that your cluster utilization is well managed. Okay, I think that's more than enough. I don't want to bore you, and as I said earlier, if you have got any doubts or any feedback, if you want me to go a little bit slower or anything, any kind of feedback, that will be appreciated. Okay, cool. Thank you so much for watching my video. If you like this video, please share it with your friends, and if you haven't already subscribed to my channel, please subscribe to my channel. That will help me, that will motivate me in doing more and more videos. And there are lots of Kubernetes videos I've planned, and I'll be uploading that in the future, in the coming weeks. And cool, yeah, and I will see you all in my next video. Thank you. Bye bye.